Good morning, everybody. Happy Saturday. Today, we are continuing something that began a while ago, and I've been working on it all summer in terms of editing the footage that I already have. And what that is, what I'm talking about, is I'm talking about ALEKS, which is an amazing program. It's a revolutionary program, and it teaches math, and it allows for self-pacing, and it allows for it provides a lot of explanations, but it really empowers students and to take math education into their own hands, which is amazing. What I'm doing is simply adding on to this amazing body of knowledge and curriculum by trying to provide video explanations with my particular brand of teaching. I hope that my students will use it this year, and now we are at part 10 of this series. And I am live streaming this sort of all in like these big chunks. I think I'll probably finish around like 15 or 18 parts. So I'm going through the entire pre-algebra curriculum. But after that, what I'm doing is I'm taking these videos and I'm chopping them up and I'm turning them into bite-sized pieces that I'm going to put into a Udemy course that people can then use to supplement their education or in terms of the pre-algebra curriculum. So that's it. And without further ado, let's get going. Again, if you like what you see, make sure to click that like button. And if you want to see more math information, if you want to get SAT help, especially for math, IC help, all that good stuff, make sure to click subscribe so you can see my stuff on the regular. Here we go. So picking up where we left off, topic, determining if figures are related by a dilation. Okay. In each part, dilate the solid figure exactly onto the dash figure. If this is not possible, click not possible. Okay. So what we're doing here is a dilation is just basically increasing it up by a particular scale, right? So you can see it increasing, but here we're trying to get to that target, which is actually smaller. So I'm guessing it's a dilation of 0.5, and let's see if that's true. And yes, that's true. So there we go. And this one, let's see if this is possible. So again, we're going down. It's a scale factor smaller than 1. And it looks like, yes, that also works. So we've gotten both of these correct. Okay, let's go to the next one. Here we go, same idea. I can tell this is not gonna work, right? But we can see, we can just double check, because once you get it down here, it's not gonna dilate to fit this, because this is a translation, not a dilation. It's a slide. So that one is not possible. And then this one maybe, let's see. Oops, we're gonna have to increase it. Yes, it's 3 times the size, so that works. Okay. All right, next one. Mean and median of a data set. If 6 students in Mr. Flores' class were asked how many minutes it takes them to get to school in the morning, here is what they answered. So these are the number of minutes, and we need to find the median and the mean. So first thing I'm going to do is I'm going to arrange these numbers from least to greatest. So I'm going to say 8, 9, 13, 13, 14, and 15. And then the next thing I'm going to do is I'm going to make sure I got all the numbers right. There's 1, 2, 3, 4, 5, 6, and I got 6 numbers here. 8, 9, 13, 13, 14, 15. That's very important that we check for accuracy. Now we want the median. So the median is going to be the middle terms. The way we find that out is we kind of cross off from one end to the other end. So like those are gone, and here's my middle terms. Okay, in this case, when we have 2 middles, we take the average of these guys. But since this is the same number, the average of 13 and 13 is simply 13. So that's my median. Now let's talk about the mean. The mean, we're adding up all these original numbers and then dividing by the total amount of numbers, in this case, 6, right? So we're adding all these up and then dividing by 6. They give us a calculator, so I'm going to use that. So we got 8 plus 9 plus 13 plus 13 plus 14 plus 15 equals 72 divided by 6, and that's of course 12. So the mean is 12. Okay, next. Same dealio, we need to find the mean and median. So first I'm going to set out all these numbers once again like this. 8, 13, 14, 16, and 16. Let's cross off to find the median. Now it's an odd number, so we got one exact middle value, which is the median, and that's 14. And now again for the mean, let's add them up. 8 plus 13 plus 14 plus 16 plus 16, and we get 67 divided by, how many terms are there? 1, 2, 3, 4, 5 divided by 5, and we get 13.4. All right, final question. A group of 7 students was asked how many hours did you watch television. Here are their responses. So same thing, median and mean. Let's set it up in order. 4, 2 4s, a 14, a 15, 2 16s, and a 20. So that's 1, 2, 3, 4, 5, 6, 7, right? 1, 2, 3, 4, 5, 6, 7. Yes. Okay, let's find the median first. Boom, boom. Cross them off until we find that middle value. There's 15 for the median. What about the mean? Well, now we add all these guys up. So it's 4 plus 4 plus 14 plus 15 plus 16 plus 16 plus 20 equals 89, and then divided by 7 because there's 7 terms, and we get 12 points. Now we're going to round up to 12.7 because this is the nearest tenth. 12.7. Make sure I got all those numbers correct, and I think I did. All right, here we go. Let's give it a shot. All right, sweet. Another topic done. Let's keep going. Next problem, data analysis and probability, identifying independent events given descriptions of experiments. So we're trying to determine whether something is independent or dependent. Now, when we're talking about the distinction, an independent event means it doesn't rely on anything. It's an independent event. A lot of times we can say, for example, flipping a coin is an independent event. There's nothing that it depends upon. A different example would be if we're talking about pulling a deck of cards, okay? And let's say we're drawing 2 cards out of a deck. The first card we draw, and let's say we're looking for clubs. The first card we draw out of a 52 card deck, let's say it's a club, okay? And we want to know the probability of that event. It's 13 out of 52, 13 clubs out of 52 total, fine. But then when we draw that second card, okay, that is actually affected by the outcome of that first event. For example, if we draw a club on that first card, now there's only 12 clubs left in the deck, and there's only a total of 51 cards left because we've drawn one out. So the second probability, the probability of the second event it depends on the first one, because it could either be 12 out of 51, or if we draw a non-club, there would still be 13 clubs in there, and it would be 13 out of 51. So that's what's called a dependent event. The first time you draw, it's going to be 13 out of 52 no matter what. It's an independent event. Now let's look at these questions here. It says a litter of puppies consists of black puppies and white puppies. A puppy is randomly selected and removed from the litter. Then another random selection is made from the remaining puppies. Okay. The first selection is a black puppy. The second selection is a white puppy. So this second selection, by the way, is dependent. Okay, whoops, I can't see. Don't click this. Oh, here we go. I have to start this. So let's actually, now we'll jump into it. For each experiment, determine whether events A and B are independent or dependent. So it says a coin is flipped, then a number cube with sides 1 through 6 is rolled. Okay, so event A, the coin tosses heads. Event B, number cube is rolled. Here's the deal. It doesn't matter what we flip on the coin in terms of what we roll in the dice. It has no impact on that second event. Therefore, we call the second event independent of the first. So those are independent events. A paper clip is randomly selected from a container with green and white clips. and then returned to the container. So we have these two paper clips. One is taken out, and then it's put back in, and then we draw again and make another random selection. Now this is very important to make this distinction. So the reason why, so these are going to be independent. The reason why is because when you remove and then replace what you've taken out, you're now going back to the original, meaning whatever you draw in the first one, it doesn't matter because you're putting it back, so you're making no impact on the second event, therefore they are independent events. A box contains assorted chocolates. Some chocolates contain only nuts and the others contain cherries. A chocolate is randomly selected and eaten, meaning it's not replaced. So now we're actually affecting what is going on, the probability of the second event. Then another random selection is made. So the first selection contains nuts, the second selection contains cherries. These are dependent because we're not replacing, we're not resetting the original batch. So again, we can, now you can kind of see that's a shortcut, right? We can look for the fact, are they replacing it or are they not? If they don't replace it, it's dependent. So it's put back. So you see this key language here, the marble's taken out and then it's put back. So in this case, these are independent because it is replaced. And then here we go, and puts it into his shopping cart. So I'm kind of skipping over the rest of it. We can see that he's taking it and he's not returning it. So it's no replacement. Therefore, these have to be dependent. Okay, and that's it. So let's check, and it's correct. Let's go to the next one. So now I'm going to be looking for that key language, and we're going to go a little faster. So she randomly selects a bottle and drinks it. Again, we're saying whatever is taken is not being replaced. If it's not being replaced, these are dependent. Randomly selects a game and sets it aside. Then we make a selection from the remaining game. Set to the side meaning it's taking it out of the sample set. So it's not replacing, therefore these are dependent. Key language. Randomly selected and put back. It is being replaced, therefore independent. Is made and returned. So it's again returned, is being replaced, independent. And last but not least, a coin is tossed twice. This has no impact on the second toss, right? If we toss a heads first, it doesn't affect the second one. The second one is still heads, tails, 50-50. So these are both independent. Okay. Oh, wait a minute. Which one did I mix up here? The first toss is tails. Oh, I see. Both tosses are tails. Wait a minute. Let me see what I made a mistake here. What's going on? So she drinks it. That's dependent. Set to the side. That's dependent. A random is an orange marble and then put back. So that should be independent. Is made and returned to the holder. So this is the only one that might be wrong, but why would these be dependent? Because the first toss is tails and then both tosses are tails. Oh, well, I guess because, you know what, I'll have to backtrack on this. I guess because for both to be tails, right, this event depends on the first event being a tails. So I guess that's what they were going for. But usually when we think about coin flips, that's because event B actually includes event A, which is a bit odd. But usually event B would be just the second coin toss, and that coin toss is not impacted by the first coin toss. Okay, let's go on to the next one here. Again, I'm going to be looking for this unique language. A hat contains slips of papers. Okay, so it's returned. Again, so anytime it's returned and replaced, we're talking independent. Set aside, not replaced, dependent. And return to the deck, independent. A family has 2 children. The older child is a girl. Both children are girls. So now it's kind of like that last example. We're looking at the event B kind of includes event A. It does depend on event A. And here we go. A number cube, 2 separate rolls. The first roll has no impact on the second one, so therefore it's independent. All right, now I'm going to kind of blaze through this last one here. Looking for that specific language. It's set aside, dependent, not replaced. Set aside dependent is rolled twice. The first roll, both rolls. When we hear that both rolls language, we're talking about the first one then is part of that second set, so they're dependent. A spinner with slices numbered 1 through 11 is spun twice. These are independent spins. They're independent events. And reinserted, meaning replaced, therefore independent. All right, done. Next topic. All right. Identifying outcomes in a random number table used to simulate a compound event. So we'd like to simulate the probabilities involved when Bob shoots 2 free throws. The table below gives a simulation of Bob shooting free throws. The table shows 10 trials. Each trial has 2 simulated free throws. Each simulated free throw is a random number from 1 through 100. Okay. And let me just make sure here. So table shows 10 trials. Each trial has 2 simulated free throws. Got it. Bob makes 55% of his free throws. We'll let the numbers 1 to 55 represent Bob. Oh, I see. Okay. So Bob making a free throw is 1 through 55. Now I understand. These are almost like percentages. I'm going to put this image over here because I want to draw on it just a little bit. Okay. So we've got, let's see here. So we'll let numbers 1 through, what is the outcome of trial 8? So trial 8, so again, 1 through 55 means he makes it. So I'm going to circle all those ones in that range. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So in this case, out of these 20 shots, he's making 10. So what is the outcome of trial 8? It looks like he's missing both of those. Oops. What's going on here? Oh, you know what? We haven't even started. So this is just the example. All right, let's click start. Let's begin. Here we go. We'd like to simulate the probabilities with genders of voters in a certain city. The table below gives a simulation of randomly selecting voters in the city. The table shows 10 trials. Each trial has 2 simulated voters. Each simulated voter is a random number from 1 to 100. So same thing. I'm going to take a screenshot. Move this over. Okay, suppose 41% of the voters in the city are male, and we'll represent 1 through 41 is a male voter. So I'm going to identify all the male voters. 1 through 41, male, 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 right? Everything less than 41, or 41 or less. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 males out of 20. What is the outcome of trial 1? We have 1 male and 1 female. The first voter is male and the second voter is female. What is the outcome of trial 5? It looks like female, male. First voter is female, second voter is male. Okay. Next. Going to be the same idea, and I'm going to take this screenshot. Now I can already kind of tell we don't really need to read that first section up top. Instead, I'm going to jump straight to the good important information at the bottom. So we're obviously talking about penalty kicks, and I can tell that from the table. Now we say my score is 59% of her penalty kicks. 1 through 59 represents scoring. So that is a score, 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 score. Okay, and that's it. 1 through 59. 1, 2, 3, 4, 5, 6, 7, 8, which is less than 59%, but this is, again, I mean, that can happen. And that's what we've identified. So what is the outcome of trial 3? Trial 3, it looks like she makes both of the kicks. What is the outcome of trial 9? She makes the first one, misses the second one. Boom. Okay, last but not least, 1 through 73, making a free throw. What's the outcome of trial 5? Well, that's miss and miss, right? Make would be under 73. So she misses both. Outcome of trial 10, 1 through 73, make. So those are both made here. And we're done. Let's keep going. All right. Identifying numbers as integers or non-integers. So what is an integer? An integer is a whole number that can be positive or negative, including 0. So it's like -4, -3, -2, -1, 0, 1, 2, 3, etc. in both directions. Fraction is no-go, not an integer. This is a whole number that's negative, yes. Decimals, nope, not an integer. Whole number, yes. Now this is deceiving because it's a fraction, but it actually reduces. 40 divided by 5, or 40 over 5, reduces to 8. Therefore, it is an integer, so you got to double check there. Okay, next one. -2/5. Fraction that can't be reduced to a whole number, no. Integer, yes. Decimal, no. That's a whole number, so it's an integer, yes. This reduces to -3, so yes. Integer, yes, because that reduces to 6. No, that does not reduce. Yes, no, and this is just -9. Next, solving a linear equation with several occurrences of the variables on both sides. Here we go. 6y plus 2 equals 9y plus 14. First things first, let's get both the variables on the same side together. So I'm going to subtract 6y here. Could have subtracted 9y, but I'm going to do it this way so I keep the y's positive. Then I have 2 equals 3y plus 14. Now that we've got the variables consolidated, let's get the numbers to the other side. So first I'm going to move the 14 because it's farthest away from y. 2 minus 14 is -12 equals 3y. And last but not least, 3 is multiplying the y. So we're going to divide by 3, do the inverse operation of multiplication. Divide both sides by 3. That goes to 1. -12 divided by 3 is -4. Therefore, y equals -4. Next question. -3x plus 15x plus 7 equals 8x plus 43. First things first, I see x is on the same side. Let's get these together. -3x plus 15x is just like -3 plus 15, which is 12, but 12x plus 7 equals 8x plus 43. This time I'm going to subtract 8x from both sides. We got 4x plus 7 equals 43. Now I'm going to subtract 7 from both sides. 4x equals 43 minus 7 is 36. And then last but not least, inverse operation of multiplication. We're going to divide both sides by 4. And we have x equals 9. All right. Last question. -3y plus 11 equals -8y plus 51. So first things first, let's get the y's together. I'm going to do the, so this is a -8y. I need to combine it with the positive 8y to send it to 0. Okay. So we don't, we look at this entity and we combine it with something that zeroes it out. That goes away. 8y plus -3y, or -3y plus 8y is 5y plus 11 equals 51. We're going to subtract 11 from both sides. 5y equals 40. And then we're going to divide both sides by 5. And we got y equals 40 divided by 5, which is 8. Next topic. Using triangle inequality to determine if side lengths form a triangle. For each set of 3 lengths, determine if they can be the side lengths of a triangle. This goes back to a basic rule, okay? And the rule is this. You cannot have a triangle if one of the sides is greater than the sum of the other 2 sides. If this relationship exists, it is not a triangle. So in this case, that doesn't exist, right? 13, none of these sides is greater than the sum of the other 2. So that's fine. What about here? This one is good too, right? I'm always going to look at the biggest side, 14.2. Is that greater than 8.7 plus 6? No, because 6 plus 8.7 is 14.7, so that's okay. Let's look at that greatest side, 29. Is 29 greater than 7 plus 16? Yes, it is. 29 is greater than 7 plus 16. 7 plus 16 is 23. So this violates that rule. The reason why, so if you think about it, if we got a length of 29, right, down here, and this is a length of 7, and this is a length of 16, these guys will never touch. They'll never touch up here because they can't cover the distance of 29. Even if we laid them completely flat, like down here and down here, they wouldn't touch. So there's no way that this could make a triangle. That's the rationale. Same thing, let's look at the 19. Is 19 greater than 6 plus 12? Yes, it is. Therefore, cannot be a triangle. Okay, next question. So now we can blaze through these really quickly. Find that biggest side. 21, is it greater than 4 and 8? Yes, it is. Cannot be a triangle. 20.5, is it greater than 3.5? 17.7? It's not. These add up to 21.2. That's okay. 15 is not greater than 14 and 4. That's okay. 16 is not greater than 15 and 8. So that's okay. Last but not least, 26 is greater than 8 and 15. So it cannot. 16 is greater than 8 and 6. Cannot. 14.3 is greater than 9.1. 9.1 and 4.6 add up to 13.7, and that's less than 14.3. So that's a no-go. 21 is greater than 4 and 8. So none of these could ever make a triangle. All right, cool. Next. Writing equivalent expressions for the volume of a rectangular prism. The figure below shows a rectangular prism. One base of the prism is shaded down here. So let's use an expression to find the volume. Here's the deal. We're talking about volume. All you got to do is take the 3 dimensions, unique dimensions of a rectangular prism, multiply them together, and you get the volume. So what we got a 5, 9, and 7. So we got 5 times 9 times 7. And I can do this in my head, I think. So that's 5 times 9 is 45. And then 45 times 7 is 280 plus 35, which is 315. Just to double check. 35, 28, 31. Okay, so it's 315. Next, find the area of the shaded base. The area of the shaded base, well, it's 5 by 9. So 5 times 9 equals 45. And the volume of the prism, now what they're showing you is you basically, for a prism like this, you take the area, this is for really any prism, you take the base area, which in this case is 45, and you multiply it by the height, and you end up with the same answer that we get on top. And that's it. Okay, next. Same dealio. So I'm going to blaze through this a little faster. We're taking those 3 dimensions, 4, 9, and 8. And we get, let's see, 72 times 4 is 288. Right, 72. And then area of the shaded base is 4 times 9, which is 36. And then 36 times 8 is 288. Next. Last one. Same deal. The volume of the whole thing is 2 times 6 times 9 equals 108. Area of the shaded base is 2 times 6, which is 12. And then we, of course, know 12 times 9 is 108. All right, let's keep going. Word problem involving the volume of a rectangular prism. The company makes wax candles shaped like rectangular prisms. Each candle is 4 centimeters long, 3 centimeters wide, and 10 centimeters tall. So a rectangular prism, again, is like a box. So I'm going to draw it out like this. So it's 4 long, 3 wide, and 10 tall. If the company used 4,080 centimeters cubed of wax, how many candles did they make? Well, we've got a total, and we need to figure out how many individual little candles we can make. So we're talking about a total divided by the volume of each of these candles. So first we have to find the volume of this candle. Again, we can find the volume by multiplying all 3 dimensions. 3 times 4 times 10. 3 times 4 is 12, times 10 is 120. So each candle takes 120 cubic centimeters. So now we take that total value, which is 4,080, and we divide it by 120, and we get 34. So they're going to make 34 candles. Okay, next. Same idea. A concrete foundation for a building has a shape of a rectangular prism. The foundation is 19 yards long, 13 yards wide, and 4 yards high. So now it's going to look kind of like this. "19 yards long, 13 yards wide, and 4 feet high." If it costs $4 per cubic yard, how much did the concrete cost for the foundation? So now what we need to do is we need to figure out how many cubic yards were used. And then we know that each cubic yard costs $4. So we find out the total cubic yards and multiply that times 4. All right, so this is 4 times 13 is 52. And then 52 times 19. Okay, so I'm kind of calculating the volume here. So let's use the calculator since they give that, because this is a bit hard for me in my head. 52 times 19 equals 988. And then we multiply this by 4 to get the cost. And it's $3,952. There we go. Last but not least, a company makes concrete bricks shaped like prisms. Each brick is 14 inches long, 8 inches wide, and 5 inches tall. If they use 16,800 total inches cubed of concrete, how many bricks did they make? Same deal. Calculate the volume of one brick, and then take that total and divide it up by the volume of one brick to get the total number of bricks. So 5 times 8 is 40. 40 times 14 is 400 plus 160 is 560. So the volume of one of these is 560. And then we need to take that total value, which is 16,800. 16,800 divided by 560. And see, they're giving us all nice round numbers. That's 30. Excellent. Okay, here we go. Word problem involving fractions and division. A road crew can repave 1/12 miles of road each hour. They must repave a road that is 2/3 miles long. How long will it take the crew to repave the road? Okay. So it's like, you think about it like this, in terms of, the fractions are always confusing in terms of what do we do? Do we divide? Do we multiply? What? So I like to change it up and make it much easier numbers. Let's say we're talking about how long will it take, right? Let's change these numbers. Let's pretend they can do 10 miles of road in an hour, per hour. And they must repave a road that is 30 miles long. How long is this going to take? Now this is really easy, right? We take the length. We know it's 30 miles. They can do 10 per hour. It's 3 hours. But how do we get that? We take the 30 and we're dividing by the rate. So it's 30 divided by 10 gives us our answer. So it's the same deal. So now we're like, okay, well, we have 2/3 total. So since it would be 30 divided by 10, but now we have 2/3 miles long divided by the rate, which is 1/12. And now we have the setup, and now we can knock it out. So let's do our fraction division. We're doing keep, change, flip. So we're keeping this, changing the division to multiplication, and flipping that to 12/1. Cross simplify. Divide both by 3. That becomes 4. That becomes 1. 2 times 4 equals 8. 1 times 1 equals 1. It's going to take 8 hours. And that makes sense, okay? 8 hours. And done. Let's go to the next one. A field that is 3/4 acres must be planted with seed. If 36 people will split the job equally, how many acres must each person plant? So again, I'm going to change the numbers up a little bit. We have 100 acres, and there are 10 people. Now let's change it to 5 people, splitting it equally. How much will each person do? You can quickly see it's 100 divided up by 5, which equals each person is going to do 20. So that makes sense. Now let's go to the same thing. We have 3/4 acres split up by 36 people. So according to that same paradigm, we do 3/4, the total number of acres, divided by 36 people, which is 36/1. Again, using keep, change, flip. Keep this as 3/4, change that divide to multiply, and then take the reciprocal or flip this to 1/36. Cross simplify. Divide these both by 3. That's 1. And that's 12. Multiply cross. And we get 1/48. So each person does 1/48 of an acre. Last one. A pipe needs to be cut into pieces that are 3/4 feet long. If the pipe is 24 feet long, how many pieces can be made from the pipe? So if it were 24 feet and we needed to cut into pieces that were each 2 feet long, I think we would see right away we're dividing it up into pieces that are 2 feet long, so it would be 24 divided by 2. But now let's change this number, and it's 24 split up into 3/4 feet. So the same logic applies. We're dividing by 3/4. And I'm going to make this into a fraction as well. And we're going to employ keep, change, flip. So this is keep, change to multiplication, and flip. Cross simplify. Divide both by 3. We get 8 and 1. Multiply cross. I get 32/1, or just 32. So 32 pieces. Let's talk about mixed number division. So again, if we're talking about division of fractions, it's all about keep, change, flip. But there's one little nuance here. We cannot carry out keep, change, flip when we've got a mixed number. So first thing we do is we convert this mixed number into a improper fraction. The shortcut way I do that is I multiply the 4 against the denominator and then add that to the top. So 4 times 2 is 8. We add that up there. Take this out. And it becomes 9/8. I'm sorry, 9/2. Okay, now we can do keep, change, flip. This becomes 2/3, or stays as 2/3. This goes to multiply, and this becomes 2/9. We cannot cross simplify, so we just multiply across, and we get 4/27. And we cannot reduce that whatsoever. Next problem. 6 1/3 divided by 1 5/6. So I'm going to convert both of these to improper fractions. So again, multiply the denominator and add that result to the numerator. 6 times 3 is 18. 18 plus 1 is 19, so we got 19/3 divided by 1 times 6 is 6 plus 5 is 11. Now let's do keep, change, flip, and we got 19/3 times 6/11. I can cross simplify here, divide both by 3, we got 1 and we got 2. Multiply across, and we've got 38/11. Now they want this in a mixed number. So the way we figure out how to turn this into a mixed number is we got 38/11. This is almost a division problem. We think how many 11s go into 38? Well, there's 3, right? So we're basically pulling 3 11s out of the 38. 3 11s is 33. So we're taking 33 out, and what do we have left? We have 5 remaining out of 11. And that makes sense because 38/11, that's over 3 wholes, and then 3 wholes with a fraction of 5/11. So that's how we do it. 3 and 5 11s. Final question, 4 1/6 divided by 8/9. Turn this into a improper fraction. 4 times 6 is 24. Oops, that's a plus, sorry. 1 plus 24 is 25/6 divided by 8/9. Now we do keep, change, flip. 25/6 times, flip that to 9/8. We can cross simplify here, divide both by 3, that becomes 3 and that becomes 2. Multiply across, and we've got 75/16. But now we need to turn this into a mixed number. How many 16s can we pull out of 75? So I believe we can pull out 4. Okay, it's the same thing. And another faster way when these numbers are bigger, we can actually just divide. And I'll show you how this works too. 16 goes into 75 4 times. 4 times 16 is 64. We subtract and we get a remainder of 11. This remainder goes on top of this divisor, and we get 4 11/16. There we go. Keep going. Okay, translating a sentence into a multi-step equation. 2 more than the product of a number and 5 equals 4. Here's how I'm going to do it. 2 more than the product is multiplication of a number, which is x, and 5. Oh, wait, they want y, sorry. Of y and 5 equals 4. And that's it. Do I need the parentheses here? No, because of order of operations. But I sometimes do it just for clarity's sake when I'm decoding one of these. So 2 plus y times 5 equals 4. Next, twice the difference. Twice is 2 times, right? Twice the difference, meaning we're going to have to put this in parentheses. I'll explain why in a second. Twice the difference of a number, y, and 9. So whenever they say the difference of something, whatever they say first comes first, whatever they say second comes second, is equal to, that's equal to 2. And that's it. So 2 times, now I need the, here the parentheses are not optional. The reason why is because of order of operations. If we didn't have these parentheses, what would happen? What would happen is the 2 would multiply the y first, then we would subtract the 9. That's not what we want. We want 2 to multiply this value. So we need to subtract first, which is why we need the parentheses, and then we carry out the multiplication. Last but not least, 7 less. And this gets a little tricky. So you might be inclined to say 7 less than the product of, but no. When we're talking about, when we hear the word less, that 7 is going to be subtracted from whatever quantity is stated thereafter. So in this case, we have the product of 6 and a number. So product of 6 and a number. And then we want 7 less than this, so we subtract 7, and that equals 2. Here again, we don't need the parentheses. I just kind of put them up there. But we do 6 times y minus 7 equals 2. Oh, it wants x. It wants x for the variable. See, that gets a little confusing because it's 6 times x, but it's okay. Finding an angle measure given a triangle and parallel lines. In the figure below, L is parallel to M, find X. Okay, I'm going to take a picture of this and move it over here so I can draw on it. Here we go. So we need to find the angle value of x. Now with parallel lines, we got some interesting things happening here. So first of all, we've got this 29 degrees, and the 29 is very important because if these are parallel, what's happening is this angle and this angle is equal. These are called alternate interior angles because this is what's called a transversal. So we know that with parallel lines, alternate interior are equal. Therefore, this angle right here is 29 degrees. Now that really helps because 3 angles in a triangle all add up to, as a matter of rule for any triangle, they always have to add up to 180 degrees. So now that I know this, we can solve for x. 29 plus 14 equals 143, right? It's almost like 30 plus that, and take away 1. Subtract 143 from both sides, and we get x equals 37. Okay, sweet. Next. In the figure below, all right, same dealio. Now we're going to use 2 different rules to solve this. So first of all, again, we have these alternate interior angles that are equal. So this is 66, that's cool. But what about this angle? We need a third angle. Well, if this is 133 and this is all on a straight line, that means this entire angle is 180. Therefore, 133, this is supplementary with 133. So it equals 47, because 47 plus 133 equals 180. Now we can use the same equation. And we will do, and there's another shortcut, by the way. When you have an exterior angle, it always equals the sum of these two, the opposite angles, meaning x plus 66 equals 133. And that's a nice thing if you can remember it. But I always say the best rule, the most reliable rule, and easiest to remember is that all of them add up to 180 and you still get the same results, just a tiny bit more work. But let's just do it that way. Equals 180, add these together. That's 111 equals 180. And then we subtract that and we get x equals 69. Okay, and the same thing here, right? 69 plus 66 is actually 1. Oh, wait. 69 plus 66 is 135. Oh, did I mess that up? Oh, I'm sorry. I made a little mistake here. It's 66 plus 47 is 113. Excuse me. Right. Okay, 113, so that's 67. And now that makes sense. 67 plus 66 is 133. Final question. So we've got this angle here that we're trying to find. And I know that this is 144. I'm going to use that same theory that these two must add up to 180. Therefore, this is the supplement, meaning this angle here is 36 degrees. 36 plus 144 is 180. 36, 87, and this is our missing angle. Now, the reason why this is important is because this angle is actually equal to this one because they are alternate interior angles, and these are parallel, so those are equal. So if I find this, this is also x. So let's use our same setup. X plus 36 plus 87 equals 180. 36 plus 87 is 117, 123. Subtract 123 from both sides. And then x equals 57 degrees. And we'll double check that because 57 and 87 again should add up to 144, and they do. Here we go. Metric distance conversion with decimal values. The tree in Susan's backyard is 8.7 meters high. Okay. 8.7 meters. How high is it in centimeters? If we're doing, actually, you know what I'm going to do is I'm going to set up my little thing here. So we've got, let's see, kilometers, hectometers, decameters, meters, decimeters, centimeters, and millimeters. The reason why I like to do this is because this makes it pretty easy. If I got 8.7 here and we're going to centimeters, we're moving the decimal once, twice. So I go 1, 2, and we can get our answers 870 meters. Oops, I mean centimeters. Okay, next. $13.7 wait a minute. Is it deci or deca? I'm going to assume it's decimeter. That's ambiguous, but this is decameter. This is decimeter. So let's just assume it's here. So it's 13.7, and we need to go to meters. So we need to move the decimal one spot to the left. So we go one spot here. So it's 1.37 meters. All right, sweet. Finally, we got 1.3 meters. And we want to go to millimeters, so we move the decimal once, twice, 3 times. So once, twice, 3 times. And then we fill in the blanks with zeros. And we've got 1,300 millimeters. So what I notice is that when this starts to slow down, I'm going to log out and log back in. That usually makes it go a lot faster. Okay. Alrighty. Sign fraction subtraction involving double negation. Negative 1/2 minus negative 2/9. Now you notice I wrote it without the parentheses because you don't really need them here. What happens when you have double negation? Minus a negative turns into a positive. So it's negative 1/2 plus 2/9. Now we need common denominators. So I'm going to get to 18, multiply this by 9, multiply this guy by 2. So we have negative 9 over 18 plus positive 4 over 18. And now we just combine the numerators, right? So we know our denominator is going to be 18, and now it's a negative 9 plus a positive 4. So that's like 9 minus 4, which is 5, but since the negative dominates, it's negative. The other way to think about it is we're at negative 9 on the number line, and we're going 4 to the right because it's a positive 4. 1, 2, 3, 4. And we're at negative 5. So that's your final answer. Okay, next. Negative 2/9 minus negative 7/6. Again, turns into a plus. And now we want common denominators. I'm going to go to 18. I'm going to multiply this by 2 and 2. This by 3 and 3. So we get negative 4 over 18 plus 21 over 18. Negative 4 plus 21 is the same as 21 minus 4, which is 17 over 18. Last but not least, 2/9, which they really seem to be liking that one, minus negative 1/5. Minus a negative becomes a positive. Common denominator is going to be 45. 10 over 45 plus 9 over 45 equals, add these top guys to become 19 over 45, and we're good to go. Sweet. Oops. Let me get this just right. Okay. There we go. Okay. Now we got sign fraction division. 12 over 5 divided by negative 9/11. Here's the deal. With sign fraction division, it's the same as regular fraction division. It's just the negatives are going to respond in the same way as when we multiply positives and negatives. If there's just one negative multiplying a positive, it's an infection. The final answer is negative. If there's two negatives, they'll cancel each other out. Two positives, of course, stays positive. So when we're talking about fraction division, keep, change, flip. 12 over 5 times negative 11 over 9. Let's cross reduce the same way. Divide the top and bottom by 3. Multiply across. And we get 44 over 15. And that's negative. And they want it as a mixed number. So how many 15s can we pull out of 44? We can pull out 2. which is pulling out 30. So we're pulling out a whole 2, and we'll have left over 14 left, and that stays over 15 negative. Negative 2, 14 out of 15. Next, we got negative 9/5 divided by negative 10. And I'm going to put this over 1. So same thing, we got a negative times a negative. That's pretty easy because those are going to cancel out. So we know our answer is going to be positive. So I'm going to take those out right away. And now let's do keep, change, flip. 9/5 times 1 over 10. So we can't cross simplify, so I'm just going to multiply across, and we get 9 over 50. No simplification possible, and that's it. Last one, negative 4 divided by, I'm going to turn this into a fraction, divided by negative 10 over 11. And this is great. Once again, the negatives are going to cancel out, so we can get rid of those. And now let's do keep, change, flip. Keep this as 4 over 1. Change this to multiply. Flip that to 11 over 10. Cross simplify. Divide these two by 2. And we get 2 and 5. Multiply across, and we get 22 over 5. How many 5s can we pull out of this? We can pull out 4. So it's a whole number of 4. And what's left over? Well, we pulled 20 out. We got 2 left over. And we got 4 and 2/5. Oops. All right, let's keep going. What's up, Mason? Okay, let's get back to this here. Writing a ratio as a percentage. Ryan spent a total of $25 at the grocery store. Of this amount, he spent $6 on fruit. What percentage of the total did he spend on fruit? So we can use this to do a nice ratio. Well, so basically, we think about it like this. We take that $6 he spent on fruit out of 25 total. So because it's a nice number that goes into 100, we could set this up as the percent proportion and solve it this way. But we actually don't need to. It's a little bit easier. Instead, what we say is, well, percent is always per cent out of 100. And since this can multiply into 100 if we times it by 4, we got to do the same to the top. We can easily get the percentage this way. The bottom becomes 100 and the top becomes 24. 24 out of 100 is 24 percent or percent, so it's 24%. Okay. This year, Milan watched 20 movies. He thought 11 were good. Of the movies he watched, what percentage did he rate as very good? Well, he rated 11 out of 20 is good. And again, we want the percent, so we want to get this up to 100, the bottom part. We do that by multiplying by 5, and we always have to do the same to the top as we do to the bottom. Otherwise, we don't preserve the fraction or the value of the fraction. And then this becomes 55 over 100, which gives us a percentage of 55%. Last but not least, Dan has ridden 40 miles of a bike course. The course is 50 miles long. What percentage has Dan ridden so far? Well, he's ridden 40 out of 50 miles. Turn that bottom into 100 by multiplying by 2. Do the same to the top, and we get 80 out of 100, which is 80%. Okay, equations and inequalities, factoring a linear binomial. Okay, all we're doing here Now we have to first recognize that these two cannot be combined. It is not 18 minus 4y is 14y. You can't do that. This has a y, this does not. They're not like terms, cannot combine them. But what you can do is you can look at this number and this coefficient and say, well, what do they have in common? Meaning, what factors do they have in common? Well, they're both divisible by 2. So what I can do is I can extract the 2 out of each of them and put it out front. So I'm going to pull the 2 out. Okay, it's kind of like dividing both of them simultaneously by 2. If I divide 18 by 2, I have 9 left. If I divide 4 by 2, I have 2 left. Or in this case, 4y, I have 2y. And now this 2 is multiplying this quantity. So when we factor this out, remember, by the distributive property, if we redistributed the 2 in, it would be 18 minus 4y, which means that this is equivalent to this original expression, means we factored correctly. So it is 2 times 9 minus 4y. I mean, oops, 2y. Okay, same deal here. We got a 6u and an 18. What common factors exist between 6 and 18? Well, actually it's 6. So I can pull a 6 out, and if I pull 6 out, I just have 1u or u, plus pull a 6, divide 18 by 6, and we get 3. And again, we can check it quickly. If we redistribute it, we get 6u plus 18. So that's right. Okay, last but not least, 28 minus 7v. Both of these are divisible by 7, so I'm going to pull a 7 out, and we have 4 minus v, right? Pull the 7 out of there, it's 1v. Pull a 7 out of here, or divide by 7, we have 4. So we have 7 times 4 minus v. Sweet. Next, finding slope. All right, let's see this. Finding slope given the graph of a line in quadrant 1 that models a real-world situation. Eric buys cheese from the local farmer's market. The graph below shows the cheese costs versus its weight. So it's cost versus weight. So you can see that as the weight goes up, the cost goes up, which makes sense. This is how usually things are priced at the market. So it's like at 1 ounce, it's 66 cents. 2 ounces, it's 132, etc. How much does the cost of cheese increase for each ounce? Well, it again looks like it goes up by 66 cents, right? And we can see that at 1, it's 66. 2, another 66, so it's 132. So there we go. And we can always find that by just looking here. And then what is the slope? The slope is the increase per 1 unit, per 1 ounce, which is 66, and that's it. Next, so the same idea. I'm not going to read this blurb because I can figure it out from the graph. So this is numbers of hours worked and the amount of money we get. So at 0 hours, at 0 hours we get $40. At 1 hour we get 50. 2 hours we get 60, and so on. What is the slope of the line? Now this is a little different because this one doesn't start at the origin. So I can't just look at the one value and say, oh, the slope is 50. It's how much is it changing every hour? Well, it looks like from 0 to 1 it changes by $10. From 1 to 2 it's another $10. So the slope is 10. It changes by $10 for every 1 hour. And again, slope is rise over run. It's rising by 10 when it goes over by 1. Rise by 10 as it goes over by 1. How much does it pay increase for each hour? Well, that's the slope. Slope is change. It's rate of change. Last but not least, we have weight, and this is the cost associated with the weight. So no matter what, we're paying $500. At 1 ton, we're paying $2,000. At 2 tons, we're paying $3,500. So I can just tell from this, jump from 1 to 2, that's a change of 1 ounce, we're going up by 1,500. Same thing, we go from 2 to 3, we're increasing by 1,500, right? 35 to 100 to 5,000. So how much does the cost increase for each ton? 1,500, right? 1,500. And then what is the slope? 1,500 divided by 1. It's the same thing. All right. Cube root of an integer. Now, probably familiar with square roots. Okay, so the square root asks what number times itself equals this number. Well, in this case, it's 2, because 2 times 2 equals 4. So what's a cube root? Cube root is we're trying to figure out what number times itself and then times itself again equals a number, meaning where can we get 3 numbers, 3 of a number, multiply, where it equals whatever the original number is. So for example, the cube root of, let's say, 27 equals 3, because 3 times 3 times 3, right? Cube root, we're having 3 instances of that number, equals 27. The cube root of 8 equals 2, because 2 times 2 times 2 equals 8. But now they're saying the cube root of negative 8. Cube root of negative 8 is negative 2. This is the case because of the way negatives multiply each other. Negative 2 times negative 2 times negative 2 equals negative 8. Why? Because negative times a negative is a positive, so these will become positive. And then positive times a negative will again go back to negative, which is why this works. All right, cube root of 1,000. What times itself again equals 1,000? This is going to be 10, because 10 times 10 times 10 equals 1,000. Last but not least, cube root of negative 216. Now this is a little trickier to figure out because it's an odd number if you don't have this memorized. But this is actually 6, or negative 6. I'm going to show you why. Negative 6 times negative 6 times a negative 6. Now we already know that a negative times a negative times a negative is going to be negative, because this is negative times negative, positive, times another negative is going to be negative. So we're good there. We know the value has to be negative. Then 6 times 6 is 36. And then times 6 again, 18 plus 3 is 216. So we know that this is negative 6. Finding an angle of rotation. A circular dial has 8 equally spaced points as shown. Point A is on the top of the dial. Suppose the dial is turned counterclockwise until point F is on top. How many degrees do we have to turn? Okay. So let's take a look at this picture over here. So how do we figure this out? First of all, going all the way around is 360. And we've split it up into 1, 2, 3, 4, 5, 6, 7, 8 chunks. Okay, so what does that mean? How much is each one of these little spaces? Well, since 360 goes all the way around and we've divided it up by 8, we can quickly see that each one is 45 degrees. So this is 45, 45 degrees for each one of these things. So we're at A and we're talking about F. So we want to go counterclockwise. Remember, this is clockwise because that's the way a clock goes. We want to go counterclockwise. So we want to go this way. So we're going to have to move it 1 of these segments, 2 of these segments, 3, 4, and 5. So we're going to have to rotate it 5 times in terms of each one of those little segments. Each segment is 45 degrees. Therefore, we got to do 5 times 45, which is 225 degrees. Okay, now we got a clock. And it says it's pointing at 3. Now it says the hand moves clockwise. So again, now we're going in, now we're going in this direction until it points at the 12. How many degrees does the hand move? So now we've got, again, 360 all the way around, split up into 12 slots, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 360 divided by 12 is 30 degrees. So each one of these is 30 degrees. So we're going until it points to the, wait, where does it want to point to? The 12. So it's going to go, let's do it in a different color. It's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to move 9 slots. Each slot is 30 multiplied by 9, and you get 270 degrees. A regular hexagon is shown below. Suppose that the hexagon is rotated clockwise about its center, so the vertex at M is moved to O. How many degrees does the hexagon rotate? All right. Rotated clockwise. So again, clockwise, we're talking about this direction, right? The same way a clock goes. So that is vertex at M is moved to O. So first of all, 360, and a hexagon is 6 spaces. So each one of those is 360 divided by 6, which is 60 degrees. So every time we rotate one letter, we're moving 60 degrees. So we want to know that M is moved to O clockwise. So M goes, let's do red. We go once and then twice. So that's 60 and then 60 again. So we're moving 120 degrees. All right. Division with a mixed number and a whole number. When we're talking about division, we cannot leave this in a mixed number. That will be problematic. So the first thing we do is we turn this into an improper fraction. We do that by multiplying the whole number against the denominator and adding that result to the numerator. So 6 plus 28 is 34 over 7. So it's like this has absorbed the whole number essentially. And I'm going to turn this whole number into a fraction. And there's a reason, because whenever we're dividing fractions, we're talking about keep, change, flip. And now this makes it easier to carry that out. So this is 34 over 7. We're keeping the first fraction, changing this to multiply, and flipping the second fraction to 1/9. Multiply across, and we're good to go. 34 times 1 is 34. 7 times 9 is 63. And there's our final answer, and we can't reduce this. Next question. 7, again, I'm going to put it over 1 straight away, divided by 2 2/3. Multiply to turn this into an improper fraction. And we get 7 over 1 divided by, this becomes 6, plus that 2 is 8 over 3. So 2 2/3 is the same as 8/3. Now we're going to do keep, change, flip. So keep this, change this to multiply, and flip that to 3/8. Can't cross simplify, so we'll multiply across. We get 21 over 8. But they want this back in a mixed number. So again, this is a division problem. Carry out the division. How many times does 8 go into 21? Twice. And if it goes in twice, that's 16. So there's a remainder of 5. And we just put that over 8. The other way to think about it is we're pulling 2 8s out of the 21. 2 8s, and each one of those 8s is a whole number because each one is 8 over 8. So that's 2. And then what do we have left? We have that 5 left. So it's 2 5/8. Next. Last but not least, 6 2/7 divided by 4. So I'm going to turn this into an improper, put this as 4 over 1. Turn this into an improper fraction. So 6 times 7 is 42, plus that 2 is 44 over 7 divided by 4 over 1. Let's do keep, change, flip. Keep that one. Change this to multiply and flip that to 1/4. Now we can actually cross simplify on this one. 44 and 4 can both be divided by 4. This is 1, this is 11. Multiply, cross, we get 11 over 7. Pull 1 7 out, so this becomes 1. We take 7 out of 11, we got 4. 1 and 4 sevenths. All right. Converting a fraction to a repeating decimal, advanced. So how do we convert a fraction to a repeating decimal? Well, every fraction is a division problem. And if we want to know what it is as a decimal, we just carry out the division. So it's 13, the numerator, divided by 18, which is the denominator. I'm going to put a few zeros here just to give me some runway. And now let's do it. 18 goes into not 13, but 130. And let's make sure to, we always got to line those decimals up. So put the decimal up top. It lines up here with the dividend in the answer. So 18 goes into 137 times, right? So 70 plus 56 is 126. Subtract, we get 4, bring down a 0. This goes in 2 times. 2 times 18 is 36. Guess what? We got a repeating decimal. Because I can already tell the pattern's going to repeat now. Bring down another 0. 18 goes into 40 twice again, right? You see how it's going to keep on repeating? So on and so forth. So it's set 0.72222, or we put a little bar on top. And that indicates that the 2 repeats. So we say 0.72. Okay, next. Write this as a decimal. So again, it's 59 over 12. We carry out the division. 59 divided by 12. I'm going to put some zeros up here as well. So 12 does go into 59. So first, let's get that value. That's 4 times. That is 48. Subtract, and we got 11. Bring down a 0. 12 goes into 110 9 times. 9 times 12 is 108. And that's 2. Bring down a 0. 12 goes into 20 once. That's 8. Bring down a 0. That's 80. 12 goes into 86 times. That's 72. Subtract. And now we found a repeating pattern. 8 again. Bring down another 0. 12 goes into 80 again 6 times. So boom. So now it's going to be 6, 6, 6, 6, 6. So we can say our answer is 4.916. So that's what we're looking for. We're looking for that infinite loop that if we keep on going, it will repeat, repeat, repeat. And then we can indicate it like this. 4.916 repeating. Last but not least, we've got 12 over 11, which is the same as 12 divided by 11. 11 goes into 12 one time. 1 times 11 is 11. Subtract, and we got 1. Bring down a 0. 11 goes into 10. 0 times. 0 times that is 0. Subtract, we got 10. Bring down another 0. 11 goes into 100. 9 times. That's 99. 1. Bring down a 0. 11 goes into 10. 0 times. All right, I see the pattern. 10, bring down a 0. 9 times. Okay, so this is very interesting. What do we see here? We don't see a repetition of 1 digit. We see a pattern of 0, 9, 0, 9. And then again, we're going to see 0. So what repeats here? 1.09. You don't just put it over the last digit. It's that pattern of 0, 9, 0, 9, 0, 9. So this is a 2-digit repeating decimal like that. And we indicate it that way, 1.09. Okay, excellent. Identifying solutions to a two-step linear inequality in one variable. For each value of w, determine whether it is a solution to -4 plus 5w is less than -19. -4 plus 5w is less than -19. So if we want to know if these are solutions, first thing we got to do is we got to isolate w. And that'll make it a lot easier. So I'm going to add 4 to both sides. And I've got 5w is less than -15. Then I'm going to divide both sides by 5, right? Inverse of multiplication, and we've got w is less than -3. So now anything that fits this will work, meaning the solution set is all values that are less than -3, meaning -4, -5, etc. 6 is not a solution. It's not less than -3. 3 is not a solution. -3 is not a solution because we want less than -3. That doesn't include -3. And -8 is less, therefore it's a solution. Okay, next. And you go -3 is less than or equal to -4y plus 9. Same dealio, let's isolate the y. We got -4y is greater than or equal to -12. Now we're going to divide both sides by -4, but this is the part you got to be careful of. When you divide by a negative, you got to flip that inequality. So -12 divided by -4 is +3. So the final answer is y is less than or equal to 3. We don't read it as 3 is greater than or equal to y. It's kind of confusing. But we always say it related to the variable. I could also write it like this. Y is less than or equal to 3. As long as the orientation of the symbol is still the same, meaning it's still pointing at the y, we're good. So any value that is less than or equal to 3 is a solution. This is all right because the less than or equal to includes the 3 in the solution. That's less than it, that's fine. This is greater than 3, that's no good. And that's less than 3, that's good. Last but not least, we've got 7x minus 1 is greater than or equal to -36. Let's isolate x. So I'm going to add 1 to both sides. 7x is greater than or equal to -36 plus 1 is -35. Then we'll divide both sides by 7. We got x is greater than or equal to -5. Is this greater than or equal to -5? No, it's less than -5. This is greater than or equal to, it's equal to -5. That's a solution. That's a solution. That's a solution. These are all satisfy that. All right. Comparing proportional relationships given in different forms. 3 airplanes are traveling at constant speeds. For each, the distance traveled depends on time as shown below. Airplane A, airplane B, airplane C. Okay. So we need to calculate the speed of each. Now, the interesting thing is these are all different ways to represent the speed, but the speed is is essentially it's the rate, it's distance per time, right? Just like miles per hour. So I can show you. Let's write it out here. Since we have a table here, I can say, wait a minute, we're going 480 meters every 1 second, right? 0 to 1, we're going 480. 1 to 2, another 480. So this is 480 meters per second. What about here? Well, this is nice because the speed is just the slope. And since we're going through the origin, we can quickly see we go from 0 to 1, we're going from 0 to 500. So again, this is 500 meters per second, right? 1 second we go 500, 2 seconds we're at 1,000. So every second we're going 500. And this last one, this is using an equation. Well, what is that full equation? This is distance equals rate times time. Rate is the same thing as speed. And what did they replace r with? 520. So this is 520 meters per second. Now we have all the values. Let's plug it in. So airplane A is 480 meters per second, B is 500, and C is 520. Which one's the slowest? What's the slowest speed? Is 480. How far does each plane travel in 3 seconds? Well, if I'm going 480 meters, well, this one's easy. It tells us right there, 1440. Airplane B is right here, which is 1500. And airplane C, well, I plug in 3 for this equation. 3 is time, right? 3 times 520 is 1560. And there we go. Next. So we've got a graph, a table, and an equation. Same deal. So we want the time, we want the speed for each. So with this nice graph, it's again the slope. What's the slope? Well, for every 1 second, we're increasing by 500 meters. Another second, we're increasing by 1,000, or by another 500. 500, 1,000, 1,500. So this is 500 meters per second. This one is 470. And we can see that just from this first jump, 0 to 470. So it's 470 every second, meters per second. And this last one, that's my speed value right there, 480. Oh, it's not centimeters, it's meters. I mean, it's not meters, it's centimeters. Centimeters, centimeters. Okay. So balloon A is 500, balloon B is 470, and balloon C is 480. The balloon that's the slowest is B because it's 470, that's slow speed. And then in 3 seconds. So I'm just gonna multiply these values all by 3. 1500. This one is 1410, right? 1200 plus 210. And this one is 1440. And we can confirm that up here, right? 1410 is what I said there. All right, excellent. This last one I'm going to blaze through. Here's my speed here is 140. Here's my speed here is 130. And this one is 120. I can see that slope, right? 120, 120. Which one's the fastest is pump A. And 2 hours is 280, 260, and 220. Or sorry, 240. All right. Table for a linear function. Now we just need to fill this out. What are we doing here? We're just plugging in values for this function for x. When we say h parentheses x, this isn't h multiplied by x, meaning this is h is a function of x. This is just like writing y if we wanted to. So this is just one variable or one value really equals negative 2x minus 1. And what we want to do is we want to figure out what is the value of this whenever we plug these values in for x. So I'm going to kind of erase that and plug in my negative 3. Now remember, these are not subtracting. These are next to each other, meaning they're multiplying each other. So for negative 3, it's negative 2 times negative 3, which is 6, minus 1, which is 5. Okay. When we plug in negative 2 times negative 2 minus 1, which is 4 minus 1, which is 3. When I plug in 0, this becomes really nice and easy because, let's go back to the original. That value becomes 0. Negative 2 minus 0 is 0 minus 1, which is negative 1. And then we got 3 and 5. 3 times negative 2 is negative 6, minus 1 is negative 7. And last but not least, we've got 5. So we're plugging in 5 for that x value. We got negative 10 minus 1 is negative 11. Okay, next, h of x equals x minus 1. So this is going to be pretty simple. We're going to replace all these values with whatever values are here. So we got first negative 5 minus 1 is negative 6. Now we got negative 1 minus 1 is negative 2. We've got 0 minus 1 is negative 1. We've got 1 minus 1 is 0. And we got 2 minus 1 is 1. Next. This one I'm going to blaze through very quickly without writing anything down. So again, it's just x minus 1. That's pretty easy. So negative 3 in for x. Negative 3 minus 1 is negative 4. 0 minus 1 is negative 1. 1 minus 1 is 0. 3 minus 1 is 2. 4 minus 1 is 3. All right, introduction to scientific notation with negative exponents. Scientific notation, we always want it to be, scientific notation is a way to represent every number. So we always want it in this format. We want it to be like 3.1 times 10 to some power. Okay, so what do I mean? Let's say we want to write 3100 in scientific notation. Well, we only want one number to the right of the decimal. To the left of the decimal. So my decimal is right here, so I'm going to move it once, twice, 3 times. So now we got it as 3.1. But it's not 3.1. It's 3.1, but then it's the same as 3.1 times 1,000, right? But we represent it very specifically. We don't write 1,000, we write 10 to the third power. So it's always a number times 10 to some power. And I get this 3, well, 10 to the third is 1,000, but I get it by seeing how many places do I have to move this decimal. I have to move it once, twice, 3 times to the left. So then we have 3.1 times 10 to the third. But now let's look at this example where we got we've got 0.006. Now my decimal's over here. Remember, I want the decimal over here. I want one whole number, non-zero whole number to the left of the decimal. So I'm going to have to move it once, twice, 3 times. And so now it's going to be 6.0 times 10. And we moved it once, twice, 3 times. So we put a 3. But it's not positive 3. Why? Because in this case, we moved the decimal to the right. So we put a negative sign on that exponent. This was moving it to the left, so it's positive. So our value is 6.0 times 10 to the negative third. All right. Next. Now we want to go back to standard notation. So this is interesting. 7 times 10 to the negative fifth. So remember, when we have a certain number of decimals and we were like if we were converting it, remember like this, it would go once, twice, 3 times, and it'd be 7 times 10 to the negative third. So what's happening is this is an indication of how many spaces we've moved the decimal. So if my decimal's here, I want to get it back to standard. I want to get it so I don't have to use this. Well, it's a -5, so I have to move it 5 spots back to the left. Okay, and the other way to think about it is this is negative, and we're going to standard notation. The final number should be smaller than 7. If I go to the right, this is going to be like 7,000, 700,000, whatever. So we want to go to the left. So we go once, twice, 3 times, 4 times, 5 times. Fill in these spaces with zeros. And we've got that answer. And we usually put a 0 in front just to make it look nice. 2, 3, 4, 7. Okay. Next. Last one. We got, 8 times 10 to the negative 2, and we want to go to standard notation. Same deal. We got a 2, a negative 2 up here, so we're going to move it once, twice to the left, and this becomes 0.08, and that's it. I'm going to put a 0 in front. All right, cool. Solving a word problem with 2 unknowns using a linear equation. A washer and a dryer cost $750 combined. I'm just going to start writing it out like this. A washer and a dryer cost $750 combined. So the washer plus the dryer equals that. The cost of the washer is, washer equals 2 times the cost of the dryer. What is the cost of the dryer? This is called a system of equations. I've just created 2 equations with 2 variables. If it were just this up here, I couldn't solve it. But now I can solve it, and the way I'm going to solve it is with something called substitution. So we want to find the cost of the dryer. So I already know that W equals 2 times the cost of the dryer. Well, if that's the case, why can't I replace this W in the first equation with 2D? So I can say 2D, replacing this with 2D, plus D equals 750. Now I've got a nice single variable equation that I can solve. 2D plus D, combined like terms equals 3D, right? Because that's 1D plus 2D is 3D. And then isolate, we're going to divide both sides by 3, do the inverse of multiply. And D equals 750 divided by 3 is 250. So the dryer is 250. The washer is 500, but we don't care about that. We just want to find the price of the dryer. If we did need to find the cost of the washer, we'd take this value and we could plug it into either equation, but this would probably be easier. And then 2 times 250 is 500, so W is 500. A total of 455 tickets were sold for the school play. They were either adult or student. So I'm going to say adult number of tickets plus student number of tickets equals 445 total. There were 55 fewer student tickets than adult tickets. So S equals 55 fewer than A. Right? So whatever the adult tickets were, S is fewer. So sometimes this gets a little confusing. Is it S minus 55 equals A? Well, no, that doesn't make sense. This makes sense, right? We can quickly plug in a value and see. If adult is 100, S would equal 100 minus 55, which is 45. And that makes sense. The student's supposed to be less than the adult. So now we got our 2 equations, and we want to figure out how many adult tickets were sold. Well, same thing. I know that S equals this value here. Why can't I substitute it in for that S up there and get a nice single variable equation? So I'm going to replace S with A minus 55 equals 445. A plus A equals 2A minus 55 equals 445. We're going to add 55, We've got 2A equals, that plus that is 500. Divide by 2, divide by 2. And we've got A equals 250. So the adult ticket is 250. If I wanted to know students, I'd plug in that adult number up here, which would give us 195. But it's not asking for that. It's just asking for the number of adult tickets, which is 250. Okay, last but not least, Gabriel's age is 3 times Mikhail's age. So first thing, Gabriel's age is 3 times Mikhail's age. That's my first equation. Very simple. The sum of their ages, meaning we add them together, is 92. What is Mikhail's age? We know that G equals 3M. I'm going to take this and replace it with the G down there. So we have M plus 3M equals 92. M plus 3M equals 4M. Oops, 4M equals 92. 4 is multiplying the M to isolate. We divide, do the opposite. M equals 23. So Mikhail is 23. And that means Gabrielle is 69, right? Because if I plug this back into this equation, I do 3 times 23, which is 69. But we just want Mikhail's age. All right, finding the mean. I think we're going to do one more, and then I'm going to call it for today. Finding the mean of a symmetric distribution. The beautiful thing about a symmetric distribution, now normally we could add up all these values. It's like 4 plus 4 plus 5 plus 6 plus 7 plus 8 plus 8, and then divide by 7. But the nice thing about a symmetric distribution is that when the data is symmetric, it's perfectly balanced. And when this happens, the mean equals the median, meaning the median is the exact middle of the data. So if we know the exact middle, it's going to be the mean. In this case, look, we can see that the middle is right at 6. So I don't even have to do any calculation. Boom. What about this guy? The exact middle is going to be right in here. Okay, see, there's an even number of points, so it's not actually 5 or 6. It's in between 5 and 6. What's in between 5 and 6? 5.5. Do we want, I guess, like this? 5.5. Okay, next. So same deal. We're just looking for that exact middle value. So what's in the middle here? 7, 2, 3, 6, and it's right in between 4 and 5. So our mean of set A is 4.5 or 4.5. And for this one, boom, very simple, 5, right in the middle. Last but not least, that exact middle here is boom, right in the middle. Right? We got 5 different rows. That's in the exact middle. That's 4. And then right here, boom, 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 boom. It's here. This is our middle. 5 and 6. What's in between 5 and 6? 5.5. All right, so that is it for now. I'm going to return to the home page. Let's see how many topics we got done. So we did an additional 66%. I'm sorry, an additional 6%, which is, we did 36 plus, let's see, 36, 6% plus 1.8. No, 36. Yeah, I think we did about like, let's say, yeah, let's say 36 topics, 37 topics, somewhere in that zone. So it's not bad. So we're getting there, 66% done. Again, going for 100% pi completion, and I'm gonna keep live streaming these, chop them up, and when the course is available for you to use to supplement your own trajectory on ALEKS and the Pre-Algebra Pi, I will let everybody know. Thank you guys so much for joining me today, and I'll see you guys next time. And by the way, if you want more up-to-date information on math, especially SAT math, all sorts of good stuff on this channel, make sure to subscribe right away, and you will be kept up to date on all that good stuff. Thank you so much, and have a great rest of your day.